Hey class, Mr. Moyden here with a help video regarding using the law of sines and cosines to solve a triangle. This is one of the harder cases. It's all three sides with no angles provided at all, which means we have to figure out what the three angle measurements must be. So the first rule of thumb is to use the law of sines when you can, which is to say when you have an opposite pair of angle and side. But since we have no angles at all, we basically can't use the law of sines, so that's going to point us to the law of cosines. Let me go ahead and add some labels here. Let's say this triangle is called F, Q, and Z. So we can't use the law of sines because we have nothing across from 30. We don't have the angle. We don't have the angle across from 22, nor the angle across from 20. So this is going to be the law of cosines. The law of cosines reads like this. There are many different ways to write it in terms of different variables, but if you just write it like this, you can change the picture to meet your requirement. So the law of cosines sort of has the Pythagorean theorem built in, and then 2ab times cosine of c. So it doesn't say what to find first, and when it says solve a triangle, what that is kind of code for is basically find all the stuff you can, all three sides, all three angles. So here it's all three angles because we have all three sides. So it doesn't say what to find first, so I'm just going to find angle z first. I just feel like it, frankly. There's no good or bad reason as to why to pick z. But what I'm going to do is I'm going to call angle z, I'm going to rename it angle c. The reason for that is there's only one angle in the entire formula for the law of cosines, and I want that to be the one that I'm going to find. That means the other two sides are going to be renamed a and b. It doesn't matter which one's which. This will still work if I had swapped where a and b are. And that means my 22 is going to be A, and 20 is going to be little b, and 30, while we're at it, is little c. So plugging everything in, we would have, let's see, try to make sure it all fits, 30 squared equals, let's see, b is 20, plus 22 squared minus 2 times 22 times 20 times some cosine of an unknown angle, which is what we're looking for. So notice that almost everything is a number except for our variable, angle c, which is what we're trying to find. So I'm going to replace a lot of these with their values in the calculator. 30 squared, I believe, is 900. Let me go ahead and find what the remaining ones of these are. I don't have the side-by-side calculator here, but you might hear some clicking in the background. That's just me calculating. So that business I underlined there is 884. This business right here is negative 2 times 22 times 20, negative 880. And that's attached to, which is to say multiplied, times the cosine of c. So as mentioned in class, a very common mistake is to combine those, but you got to keep in mind those are not like terms. This does not have a cosine of c attached to it. So what I'm going to do next is I'm going to subtract 884 from both sides. And that'll give me 900. I can probably do that in my head, but it's the end of the day. 16 equals 880 cosine of c. And of course, don't forget this negative. Left there off on purpose. Very important to keep that in mind. So we have cosine of c almost solved for, so all I've got to do now is to isolate cosine of c by dividing by this negative 800. If that's right. Yep. So 16 divided by negative 800 will give me negative 0.02 equals cosine of c. Now the fact that it's negative might be a little bit concerning. I wouldn't worry too much. I think we can work it out in just a bit. But let's take a look. If I can give myself a little more room. Okay, so c is what I'm looking for ultimately. C is right now in the embrace of the cosine. It's cosine of c. So what I'm going to do is I'm going to invert this statement by putting c all by itself in the place of the ratio, and then I'm going to put the negative 0.02 in place of the c, and I'm also going to invert cosine to give me inverse cosine. So if I do inverse cosine of this ratio, I should get an approximation for the angle measurement, and the angle measurement is approximately, according to the calculator here, 91 degrees. Now right away you can tell that this picture is not drawn to scale because this is supposed to be 91 degrees, and as you can tell it appears to be drawn acute. That being said, this is the longest side, 30, and thus this needs to be the biggest angle. And you can see it has to be because no triangle can have two obtuses, so the other two must be acute. So that fit at least seems to work out. So we have one of our angles, that's good. We're basically 1/3 of the way done. We have 2/3 remaining, but we do have our side by using the law of, our angle rather, by using the law of cosines. So let's see what else we can find. Still have two other angles remaining. Oops. So now that we've found this value, let's see what else we can find. We have this, remember our problem-solving protocol essentially says use the law of sines when you can't, unless you can't. And we had to use the law of cosines to find this 91 right here. But now that we have it, can we now use the law of sines? And what we realize is we can, because we have this complete pair of side and angle. So now the law of sines is accessible to us. So these two are paired together. So one of my statements could be that the sine of 91 degrees over its opposite side of 30 is going to be equal to the other two pairs. Now it also doesn't specify what the next angle is to find. I'm just going to find angle A because I feel like it, but you can do this also with angle B if you wanted to. So an unknown measure of angle A is corresponding with the side length of 22. So sine of angle A over 22. And if you wanted to complete it, you could say that sine of B over 20 would be the third part of this, equation. But for our purposes, let's just find angle A and see what we can do with that. So I'm going to see if I can find angle A. The best way to do that appears to be to cross multiply. So let's see, if I do that, I would get 22 times the sine of 91 degrees equals 30 times the sine of A. My ultimate goal is to find angle A. So let's see if I can get rid of this 30. It's multiplying, so if I divide, that should take care of that. And if you'll notice, there's quite a bit of technical language being used here. 22 sine 91 divided by 30. The other side is merely sine of A, right? So I'm going to go ahead and type this in the calculator. I'm going to type this part in first and get an answer and then divide that result by 30 to give me sort of a decimal approximation for what 22 sine 91 over 30 is. So the numerator is about 21.996 divided by 30, and I get approximately 0.733. I'm going to use the exact value for my calculations, but it's about 0.733 for the sine of A. Anytime you're looking for an angle, just like in the last problem, an inverse is probably going to show up unless there's an easier way, as we'll see in just a bit. But for now, in order to find angle A, I'm going to invert rather, it's the verb form. The ratio is going to go in place of the angle measurement, which we don't know, and sine is going to become inverse sine. So essentially everything has become its doppelganger, its opposite. So inverse sine of the exact value, so 0.7332, etc., using the calculator, gives me an angle measurement of approximately 47 degrees. I'm getting 47.157 here, but 47 degrees is sufficient for most operations. So that's going to be 47 degrees. And now we're 2/3 of the way done, right? We have two of our three missing pieces, the angle 91, the angle 47. We have only this third angle remaining. And I suppose we could do the law of sines to find it, not a problem. However, let me clear up the picture a bit. We already have two of our angles. All triangles, of course, add up to 180 degrees, one of our very first proofs. So 180 degrees in total, removing the 47 and the 91 that we found, leaves only a certain amount left over for our third angle, and let's see what that is. Too late in the day for any mental math. I'm going to get 42 degrees. So my third and final angle would be 42 degrees. So to summarize, we started with a pretty difficult picture in that we had no angles to build from. We didn't have this 91 just yet. We couldn't use the law of sines because we had no angles to pair anything up with, so we had to use the law of cosines. The key part to make this relatively straightforward, I mean, not to say it's necessarily easy, but the key idea is in order to use this form of the formula, no matter what your picture is, you have to redraw your picture to meet the formula's demands, which is to say the picture needs A and B and C regardless of what you're given. And you want to be mindful about how you relabel, which is to say, if you're looking for a particular angle, and I just chose to find angle Z first, I went ahead and called that big C by design so that I could find it in the formula. Little c, therefore, was locked into being 30. The other two, therefore, had to be A and B. Does not matter which one is which. So that relabeling allowed this to follow from this one form of the formula. Once we had that angle, We could then use the law of sines, as we did, to find the one of the remaining angles. Again, choosing sine of A here was just a choice. We could have done the same math, or similar math, to find the sine of B instead, or the value of B. And then all triangles make 180, so you can find the remaining angle by the triangle angle sum theorem. So here are our three answers to this problem. Hope this helps.